Okay, let's give you guys some practice. So sketch this graph here, y equals 2 sine 4x minus 90 plus 1. So you've got to visualize this as being a bubble here. Remember, sort out this bubble first. Here you've got a coefficient of 4. The coefficient of x here is 4. So be careful. It's not a matter of shifting it by 90. And once you've sorted out this bubble here, you've got to well, here you're changing the amplitude here, okay, and then later on you're going to shift it vertically, or well, you're going to shift it in the vertical direction here by 1. Okay, so there's a mixture of everything. So press pause and have a go. Okay, so to do this here, rewrite this so that you have a coefficient of x to be 1. So let's rewrite this as 2 sine and then this. Take the 4 out as a factor. So it's going to be like this. 90 over 4. You see, by writing it like this, we can actually see this this transformation later on. Okay, so once it's in this form here, let's start with our function. Let's say we've got a function. Let's start with f of x equals sine of x. Start out with this, and then slowly start out as this. Then slowly we will transform it into this whole thing here up here. Okay, so sketch this graph first. So this will be something like this. Our standard sine of x will be like this. Okay, so this here is 360. This here is 0. Okay, so starting here, our first transformation would be this 4 here. So our next transformation would be this 4 of x. Then that would give us sine 4 of x. Well, sine 4 of x, we can well, when we apply this transformation 4 of x here, we are squeezing everything inwards here. Okay, so now the sine will get squeezed inwards. So it's going to be this. So the period here would be 90, because because you've got 4, 1, 2, 3, 4. So you're squeezing everything inwards. Well, anyway, applying this transformation here would give us this sine, this graph here. Basically, we are squeezing everything inwards. Okay, and then from here, you see, our next transformation would be this: f of x minus 90 over 4. Okay, then that would then give us sine 4, and remember, we are putting this thing into this thing here. So that would be hang on, let me think, x minus 90 over 4 here, and then close it off. So this applying this transformation means we are shifting everything to the right by this amount here. That was the whole point of us starting from here and rewriting it in this form here, just so that we can identify this bit here. You see, this bit here tells us that we should move it to the right by 90 over 4. Okay, so when you come to sketch it, so applying this transformation here will give us a graph like this. So at the moment it's here. So at the moment, so this sine 4x here is this graph here. Okay, now we are going to apply this transformation, meaning we're going to shift everything to the right by we're going to shift everything to the right. Hang on. So this gap here is actually 90 over 4. Okay, and then our next transformation would be so we've done the whole lot here. Now our next transformation would be this one here. So our next transformation would be this. Hang on. Our next transformation would be this 2f of x. So 2f of x means we're going to change the amplitude. So at the moment, but by applying this transformation here, we will have this 2 sine sine 4x minus, oh, this is ugly, hang on, we're going to have this 4 bracket x minus 90 over 4. Let's stick the whole lot in brackets here, so we should do the same up here as well. Okay, but now, so we previously we were here. Now we're going to apply this transformation, meaning that we will get a graph like this. So at the moment the height here is 1. By applying this transformation here, we're going to change the amplitude, so it will be 2 up here, 2, and down here would be negative 2. So our graph will now look like this. Okay, so now this here is negative 2, and this here would be positive 2. Okay, now looking at this here, our next step is to add this one here. So what we're doing now, our next transformation here would be this. Hang on, our next transformation would be f of x plus 1, giving us giving us 2 sine bracket 4x minus 90 over 4, close it off, and then we're going to add 1. So what that means is whatever our function was before worked out, the whole thing worked out plus 1. So the whole thing worked out is this here, and then we're going to add 1, meaning that at the moment it's 2, so it's going to be 3. This one here, negative 2, add 1 will be negative 1. So our graph, so our next transformation here, so yeah, our next transformation would look like this. It would look like this. Hang on. Well, I'm going to draw it over here actually, because well, we can see it. We can use this graph here. So at the moment is this here is, well, let's use the highest point. The highest point is 2. So when you add 1, it will become 3. So let's say this is 2 here, 1, and this here, 1 here is 3. So it's going to be it's going to be 3. Okay, this bit here will be 3, and this here will be 1. So this point here is this point here, because at the moment it's 0. When you add 1, it moves it up to 1. Okay, so the lowest point here, which was negative 2, when you add 1, it becomes negative 1. So this one here is negative 2, negative 1. So negative 2, when you add 1, it will become negative 1. So it's going to be somewhere here. Okay, so well, it's going to look something like this. Yeah, it's going to look something like this. Okay, so this point here was 0. When you add 1, it takes it to 1. So this thing here, well, it will look like this now. Okay, and then you fill in the rest really. So it will continue like this, and so on over here as well. Okay. Well, anyway, that's yeah. So your end graph will look like this. Okay.